Hi guys, welcome to today's lesson. So today we are doing some revision of finance and growth. Guys, we've done a number of concepts under this topic. We've done a number of things that I wanted you to see and see the bigger picture with. So now we're just going to put everything into perspective in terms of questions and try and show you which option is better. Is it better to save? Is it better maybe at times to take a loan? You know, those things that we're going to talk about. But just a disclaimer, remember that nothing that I say serves as financial information for you, but it is just me running the numbers because I'm just a numbers person. And that's what mathematics is about. So let's just jump right into it and do just a quick recap of where we come from and what we've done so far, and then start with today's lesson. So stay tuned. Now remember, today our main thing is finance and growth, which is in mathematics. And then we've looked at the concept of growth as the big idea. Under this, we looked at what we call patterns, and that's how we saw growth happening, to say growth is in the form of a pattern. It might be a linear pattern, it might be a non-linear pattern, but we know that growth is about being a pattern. And the pattern then led to us drawing some graphs to show the correlation of maybe number of years with the amount that you are saving or the amount that maybe you are investing. That's what we looked at. And then we looked at also the equations, which we called our models, to assist us in trying to predict what will happen in the future. Now the context, remember, it was very important for us to look at growth in terms of context. First, we looked at the society, we looked at the things that are happening in our country, all over the world, the coronavirus, all of those things, like everything that had to do with society and how growth is taking place in that regard. That was the first context. And then we pinned it down to mathematics specific growth, which was then finance. Now, right now we're going to look at patterns because that was our really big idea that you're going to be taking further as well as you progress with your mathematics career. Remember, patterns are in three forms. It's simple patterns, compound patterns, and random patterns. But specifically now, I'm going to look at first questions that have to do with simple patterns. Now, the first question that we're just going to start with is, Jenna invested 3,500 in a bank, right? So this is an investment, meaning she deposited the amount and left it there. Now, the bank offered her 6.5% per annum simple interest. Remember, it's very important for them to let you know which kind of growth we are dealing with. Is it simple, random, or compound? Though with random, you're not really going to be told that this is a random growth. You will just see with the numbers that it is a random growth. Now, what they want us to do is calculate how much Jenna will have after 5 years in her bank account. Now, remember, guys, simple interest is all about having a common value that is being added each and every year. So one way of doing this can be to find out what is the interest for 1 year and then multiply that interest by the number of years and add it to the initial amount. That's one way of doing it. Remember, before we looked at the formulas, that's how we're doing it. But because maths has made things easier for us, we then use a formula to do this, which is a simple interest formula. So firstly, remember, you need to start with writing down your data so that you know what is it that you are given, what is it that you do not have, and what exactly is it that they want you to find. And then you can start calculating. So if we start with our data, remember they want us to find the value of A, which is our accumulated amount. But now what we are given is the principal amount or the present value, which is 3,500. That's what Jenna started with, her investment. The interest is at 6.5% per annum, and this is on a simple interest. I will just say SI there. And the number of years is 5 years. Now you always need to start with also your formula after writing the data. 1 plus I multiplied by n Then the p-value is 3,500 into 1 plus, remember our interest is 6.5, so you divide that by 100, it gives us 0.065. Multiply this by the number of years, which is 5 years. Now if I just go to my calculator, this will be 3,500, open a bracket. Please guys, remember that you don't really need to be doing mental maths here. We have a calculator for a reason, so use it wisely, please. And this will then be our answer. So Jenna will have 4,637 rands. And remember, if it's comma 5, you add a 0 at the end so that you say and 50 cents and not just comma 5, because we're talking rands, which is money. So this is 4637. 4637 and 50 cents. And this is how much Jenna will have after 5 years in her account. The second question, 7 years ago, so this is in the form of past tense, a certain amount of money was invested in a bank. Immediately they say a certain amount of money, we know that's the value of P that we do not know anything about, but the value of the investment is currently sitting on 350,000. So the accumulated amount after 7 years became 350,000. Calculate the original amount invested if the interest rate was 3.25% simple interest. Remember again, you start with your data. And if you start with your data, this is what you're going to have. The A value is 350,000. The P value, we don't know anything about it. I value will be the 3.25, and then N will then be 7 years. So my formula will be A is equals to, remember guys, you always need to start with your formula, please. It makes life easy whenever you're substituting so that you don't misplace values when you are busy substituting. So this is 350,000 is equals to the P value, which we do not know, 1 plus the interest, they said it's 3.25, so that's 0.0325 multiplied by 7. This was for 7 years. And then I'm just going to go straight to the calculator. Remember not to round off whenever you are busy calculating. So I'm just going to do it as one long calculation and get the final answer there. So 1 plus 0.0325 multiplied by 7, and that's what will be in my bracket. And then I will say 350,000 divide by the answer that I just got, because I'm avoiding having to round off as I'm busy calculating. So this will be 285,132. So the P value will be 285,000. Let me just verify quickly. 132. 132 and a few cents there. So that will be the original amount. So you will then always need to say, therefore, the original amount was, and that's how you will conclude your calculation. Another question now is, how long will it take? So we look at what does how long mean. How long will mean we want time, right? We're talking about time, which is duration. In financial maths terms, we know time is represented by N, which is the number of years. It will take for an investment of 50,000 to increase to 65,000 if the interest rate is 5.5% simple interest. So this will then be, remember I'm always also gonna go back to my data that I need to write. So this is A is equals to P into 1 plus I multiplied by N, right? The A value is still the 65,000 that they just gave us now. The P value is 50,000. And we are looking for the N value. 1 plus This is 0,055 multiplied by n. Then even with this, I'm just gonna do it as one long calculation. So this will be the same as 65 divided by 50. This is just algebra, guys. You guys can do it step by step, but please just remember not to round off your answer. I minus 1 there, and then I will divide this by 0,055. And that will give me 5,45. So roughly, I will say n will be equals to 5 years, because you will need to round it off to the nearest number of years. And then you can then continue maybe and convert the decimals into months. But it will approximately take 5 years for this amount to grow to be 65,000 at that interest rate. Calculate how long it would take for an investment of 9,000 to double. Now here also we're still talking about how long, and now we're talking about it doubling. So here, guys, whenever you see the word double, remember whatever the initial amount was, you're just gonna times that by 2. You're not gonna make up your own values here. So it was 9,000. For it to double, it means it must be 18,000, and then you want to find how long will that take place for it to double up and be 18,000. So my A value, I left it blank so that we know what is it that we're going to do there. We write 18,000, and then remember again the formula, 1 plus I times n, and then my A value will be the 18,000, and my P value will be the 9,000. That's what we started with. 1 plus my interest is 0,11 times n. So even here, I'm just gonna go straight to the calculator. So I have 18 divided by 9, which is gonna give me 2, and then minus 1 there. You divide this by 0,11, and it gives me that. So it will take roughly 9 years. So it will take 9 years for an amount to double up at simple interest. Hey, investments, guys, or saving is really not a fun thing to do, though it's very necessary. So guys, so far we've looked at how to calculate the accumulated amount given the principal amount. We've also looked at how to calculate how long an investment will take. So let's just also continue and see exactly what is it that we can do after in terms of calculating what needs to be calculated. Here, I want us to find the simple interest, and this will be the last question that we are doing under simple interest for now. I want us to find the simple interest rate that Paul got when he invested 35,000 and it grew to being 55,000 over a period of 5 years. So I still go back to my formula. I know it's tiring to write the formula, but it's really necessary, because then you are avoiding these little mistakes that we normally make when nerves are playing with us in an exam situation. So this is 35,000 into 1 plus, I am calculating n, my number of years is 5. Similarly with this, I'm going straight to my calculator. 55 divided by 35, it gives me that amount. I will subtract 1 and then divide this by 5. It gives me 0, that. Then you will just multiply this by 100 to get it to be a percentage. Then my interest is 11.43%. So this will be 11.43%. All right. So guys, I hope that puts a lot of things into perspective with what we've been doing so far. Remember, simple growth is about having a constant value that is being added over time, right? So we've looked at an accumulated amount. We've looked at calculating the value of P if we know what the accumulated amount is. We've also looked at calculating the how long part, meaning the number of years. Now we're looking at also calculating the interest rate. Remember that all of this is only going to be easier for you if, one, you make sure that you remember what your formula is. Number two, you always write down your data before you can perform any calculation, and then always avoid rounding off in the midst of your calculation. Only round off when you get to the final answer. Guys, we'll be back with some more. Stay tuned. Let's just quickly go to an ad break and we'll be back.